Hello, fellow FreeBSD nerds. In this video, I'm going to cover how to install FreeBSD with a custom 14.0 stable installation image from FreeBSD's source code repository. I'm installing from custom media because I'd like to encrypt my user's home directory with the adduser script changes that I've been working on in my previous videos in this series. I've got an older ThinkPad T480 that's been my main FreeBSD laptop for a long while now, and it's time to upgrade it to 14 stable. I'm currently running 13.2, and I use Geli to encrypt the entire drive right now. It's an NVMe drive, and I'd like to move to just using ZFS to encrypt my home directory. As far as I'm aware, the biggest downside to encrypting just the home directory with ZFS encryption instead of Geli is that currently there's no real support for logging into the system with a GUI and having the drive unencrypt automatically. I currently use KDE as my FreeBSD desktop, so it means it'll be no decrypting from an SDDM login. For me, this isn't a big deal since generally I boot my FreeBSD system straight into the console, even on the laptops. I've done this for most of my Unix/Linux systems over the years, since many times I don't need a GUI. I just want to jump straight into a console to get into tmux and start writing code or checking email or whatever. So in this video, I'm going to cover about creating the installation media and then installing it on the laptop, using it to install the laptop. Thanks.
So this is a FreeBSD system that I use for recording, or I use for testing FreeBSD changes and compiling the repository. It's pretty straightforward. AMD 24 core system. So you can see. And I'm going to use it to download the source. That's the first thing you need to do. Clone the GitHub repository. Directory 2. Very straightforward. It's pretty big. It's an old project. There's a lot to it. So it's going to take a few minutes for it to download. All right, finally done. Took about probably, I guess, almost 10 minutes to do that, to get it all, just because of internet connection. I have a pretty decent internet connection here. The is 2.69 gigs. That's almost 3 gigs. That's pretty amazing. FreeBSD was not that big when I first started using it. So now we have our handy dandy repository, Git repository, with the current up-to-date FreeBSD changes, commits from December 4th. All right, cool. So now what we can do is we want to check out, I want to run 14 stable on my laptop. And the easiest way to do that is to check out the 14 stable branch. I hope I can check. Spell 14 correctly, or stable correctly. So that's a pretty quick thing to do. Check the log. All right. Ooh, PF control. So changes 14 stable. So these are stable changes that are going, or these are changes to the source tree that have been deemed are stable and are going into the stable 14 stable branch that will sooner or later be merged into a release. So think like 14 .0 P1 and P2 P3, and then in the future 14.1 and then 14.2. So this is what I want to run on my laptop, but the change that I need to make to the adduser script, I currently have in a file in temp. I think, oh, that's a diff. That's the code that I wrote mostly in those videos, in those previous videos. So I want to patch this current repository with those changes that I made. So I'm basically patching 14 stable with my custom adduser script. And it looks like it succeeded. Yay, excellent. So now I should be able to get status and see, yes, several files have changed. Do a get diff just to see what the changes are, and yes, that all looks correct. Excellent. So now what I want to do, this one takes a while. Now what I want to do is recompile or compile the repository from scratch. This is cool because this is going to compile the entire FreeBSD operating system, and the system I'm compiling it on is running. I'm running 15 current. But this you can compile an older version of FreeBSD with a newer one. You cannot go the other way. So you can't compile a 14 system with a 13.2. You might be able to, but I've always had difficulty with that. I almost always compile using current or using the existing system. So compile a 14 system with a 14, or compile a 13 system with a 13. But I always usually have a system at my one of my systems is running whatever the latest current is, and that's where I compile from. So the first thing we need to do is compile to create all those binaries for the installation. And the way you do that is run make build world, but we want to make build world with the J option that says how many parallel executors, parallel jobs you want to run, because if you just did it with a single job, it would take forever. And I've got 24 cores in the system, so I'm just going to make with 20. No, actually, I use 24. I do 20 sometimes if I still want to do desktop stuff or I'm recording anything with OBS. So I'll do 24 cores and want to first build world. Because this will build all the binaries, including the adduser script, and put them into a directory under the user object, under user object, the user object directory. So let's start to execute. Actually, there's a better way to do this. Send it off into dev null. That way, and get a handy dandy control T and see how long it's been executing. Awesome. All right, one of the things I like to do when I'm compiling FreeBSD is I'll run top, search make, hit A, and I can see what is it currently working on. So right now it's working on LLVM and Clang because it's building, essentially it's building the build tools. And this is I think this is the longest single thing it has to build when you're making, when you're building world. It's building the build tools. Takes a long time. All right. I will check back once this is done. Usually takes about 15 minutes on this system. So you can see here. Yep. It's gone for a minute so far. All right. All right, appears to be done. So now we can build the kernel. All right, let's build the kernel. So that is just a make build kernel. It generally doesn't take nearly as long as the building the world. So kick that off real quick. Actually, we can do this. Let's send it into T. Temp build kernel. And so that way we can send it straight into a out. No. So we can check on the progress without losing all the data. So we should be able to now do our top make yeah, kernel out. There it goes. All right, excellent. This will take a few minutes, not too long though. But we can use our Control T trick to see how much time it's taking. So we're at 36 seconds. So yeah, I'll let this go, and I'll be back when it's done. Excellent. Took 143 seconds to build that kernel. Not bad at all. Okay, now it's time. We've built the kernel, we've built the world. Now it's time to make a release. So in the source code that we downloaded, there is a directory called release. Now, what release is, it's a make file that contains all the scripts necessary to make an actual release of FreeBSD. So you can make a CD-ROM image, you can make a DVD image, and you can make a memstick image. For our purposes, I want to make a memstick image because my laptop does not have a CD-ROM or a DVD ROM. Because it's relatively modern. The T480 is old, but it's not that old. I think it's from 2018. So you do, however, when you're making a memstick image, you have to run it as root, mostly because in order to have chroot access, in order to make an image, you need chroot to create a fake root that is then has all the files for installation installed inside of it, and then that chrooted chroot is then used to create an image. So you basically run make memstick, and I don't use the data. Oh, I've done this before, so I can make clean, and then we'll make the memstick once I do the make clean. Make memstick. There we go. And I will be back once this is done. It usually takes about 10 minutes or so. All right, the memstick is done being created. Looks like it's roughly what 12, about a gig, a little over a gig, 1.3 gigs, and it should be. So when you're making the release, it actually gets installed into the user object directory, like I talked about before. So we should be able to jump into that directory, release. Look in this, or no, that's memstick right there. Memstick, there it is. There we go. 1.3 gigs. All right, excellent. So now we can take that image and DD it to a, if we have a drive, which I do. I've got a little sand cruiser here. Plug into the system. All right. And here it is, DA0 sand cruiser. USB config. Sand cruiser, yeah, there we go. All right. High speed. Ooh. All right. So now I can use DD. Yeah. Memstick. Block size equals 1 megabyte. And equals dev DA0. There we go. All right. Again, we can use our Control T to see how much has been written and how fast it's going. So this will be, it's in bytes, so kilobytes, megabytes. Roughly. Megabytes per second. There we go. 7 megabytes per second or so. Nice. Pretty good. Hey, all right. Excellent. Looks like it took 160 seconds to write 1.3 gigs. All right. Now it's time to jump over to the laptop and we'll start installing and see if the script, the adduser script works by encrypting the home directory. We start with rebooting the system and watch it reboot. Sync nodes. All right, this is a reboot of the T480 laptop. It is set up with a to boot the USB stick, the memory stick that we just created. And so I'm jumping into the boot menu to tell it boot the SanDisk Cruiser. And in order to unlock the drive, Gelly is going to want a password first. Now that will go away. That's going to go away once we reinstall the operating system. FreeBSD menu, just go ahead with the default options. Now it's booting off the USB drive. And this is 14. This is the drive that we just made with the make mem stick. Booting. All right. Now we're at the FreeBSD installation. Let's go into defaults. This system is called Arachnid because I like spiders. lib32 is fine. Yes, we absolutely want auto ZFS. The whole point of this is ZFS. And let's double check everything. Stripe 0, yes, 0, it's fine. 4K sectors is fine. GPT, yes. Mirror, encrypt swap. No, I don't think we need to encrypt the swap. All right. Did I do a good enough backup? That's the question. Yes, I do backups on my systems all the time. So yes, I have a recent backup. All right, now I just blew it away. So it is now reinstalling FreeBSD onto the local Samsung NVMe, and it's copying the tar GZ files or the tar XZ files, which is compressed tar files, compressed tarballs. They're now going to be installed on the local drive, and it basically just extracts it to the local drive. Okay, so this is the root password. So I need a root password. All right. Which interface should I use? EM0, yes, I want IPv4. I'm just realizing now I don't have a cable plugged into it, so I'm going to jump past all this nonsense about not finding DHCP and worry about it later. All right, yep. UTC CMOS clock, it's fine. Set the time zone. I'm in the eastern United States. Okay, yep. And skip all this. I'll settle this up once the system's up and running. Definitely NTP, definitely NTP sync and start. Don't need all that. Yes, I want to add a user. This is the magic. So the question is, does the script work on the laptop? It's a little blurry. Need to make that, need to focus. Focus! There we go. That's better. All right. Grafton. So in theory, I should get a question about would I like ZFS encryption? So home J Grafton, that's fine. Enable ZFS encryption. Yes. All right. Password-based authentication. Yes. Random password. No. Enter a password. enter it again. So it asks the question now. Hey, all right. Now it's actually asking the passphrase or the key phrase for the CFS key. Now, if you make this the same as your password, you'll be able to set up a PAM entry in your PAM conf file that will allow you to log straight in as a user um, and decrypt the home directory when you log in. That's not going to be set up by the adduser script, so that's something they have to do manually afterwards. So if this worked, this laptop should just boot. All right, that's good so far. Good so far. Looking good. Looking good. All right, booting, 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 and I'll have to log in as root to see if that home drive is encrypted or not. So it's booting. It looks like it is 14 stable. I think I saw that go by real fast. Yep. So login as root. ZFS list. Excellent, excellent. Okay, there it is. Z root home J Grafton. Now I want to make sure encryption is enabled on Z root home J Grafton. If I could type. Hey, all right. So the encryption value is AES 256 GCM, which is the default. Excellent. So load the key, which asks for the key phrase. See, this happens automatically when you set up PAM to do it. But right now, since that's not set up, I have to do it manually. All right, log out. Log back in as jgrafton because I should have a home directory. And excellent! All the files are there. They got copied during the installation. Yay! That's not that interesting of a yay. Can we make it yay a little more interesting? Yes, yay. Yay!
So there you have it. A brand new FreeBSD 14 stable installation with a ZFS encrypted home directory on a T480 ThinkPad laptop. The encrypted home directory code has not been accepted into mainline FreeBSD, so this procedure does not work on a released version of FreeBSD. It only works if you have the patch, which you can get from the GitHub pull request. Much like the rest of FreeBSD, this is a very manual process and getting it installed and set up. But frankly, that's part of FreeBSD's charm. It's an operating system that you can configure any way you like. Well, that's it for me. I hope you enjoyed this video, and I'll see you guys later, and thanks for watching.